Again, can you confirm naka-disconnect yung headset ko eh. Naririnig ako ngayon ng malinaw ngayon. Naririnig ako
Ye-
ng malinaw ngayon.
Yes po.
Okay. Um, again, good morning. So, let's first check your attendance. No? By the way, we will not be consuming naman yung 4 hours um, of our lecture na to discuss. Maybe half of it. No? Kasi meron tayong mga topic to discuss. Okay. Cordeta ba is here? Enriquez, Gante, Humawid, Marcos.
Humawid po, sir.
Nakamali ako ng click. Humawid. Nasaan si Humawid? Ito. Marcos, Mateo,
Mateo
Roluna.
po. Mateo present.
Okay.
Sir Enriquez po present.
Roluna. Kindly wait for another roll call. No?
Tobias po, sir, present.
Saavedra, Tobias. Okay, another roll call. No? Okay, I'll do it in order para hindi magulo. No? So, last roll call before we proceed. Bardinas, Barlaan, Bautista, Belo.
Hello po, sir. Present.
Belo is present. Cordeta. Enriquez is present. Gante. Marcos, Roluna, Saavedra. Okay, so yun lang for our attendance. Now, somebody's asking me sa GC if merong points for the engineering week. What do you think? Wala po na lang, no? What do you think? May nalungkot, no? Hindi, actually, I'm thinking about it kasi I think yung iba kong co-faculty naman is acknowledging the participation, no? Giving some point. But again, no, with your participation, it does not necessarily mean naman na you're automatically pass the course, no? It's just maybe a point of addition to some low scoring activity. But again, there's no assurance. Pag umattend kayo doon, you already sure pass the course, di ba? So, sige, I can give some points, but I'm still finalizing it, no? Sa lahat naman ng courses ko yung mag-a-apply. Okay, lahat ng hawak ko na subject. Okay, so wala pang hindi ko pa pina-finalize kung ano man yung points, kung ilan or saan, no? But rest assured, no, if you join, then meron din sa akin na additional points. Okay, so but of course, yung purpose naman is to somehow for you to loosen up, no? Hindi lang puro aral, somehow you can enjoy your stay on the school with that activity. Okay, yun naman yung main purpose na. But sige. Okay, since most of you are requesting for that, then I can give it naman. Okay, so let's of course proceed with our agenda for today, yung ating discussion. Can you confirm, class, you are seeing my presentation here?
Yes po, sir.
Okay, I would like you to bring out your calculator already. Okay, and also listen very carefully. No? And kung merong question, feel free to ask, no, kung nalilito kayo. Okay, so for today, we will be having some more example computation for the topic share and moment in beams, no? With our two equations, simultaneous na, no? Equation method and afternoon area method, no? Para we can apply both per problem. And after that, no, after those examples, we have the example here, no? For share and moment in beams. Then after that, we go to the topic about moving load. Okay, so for now, let's start para of course makausad tayo na with our topic for today. Okay, so class, let's start for this problem, sample problem 4.3. Okay, kindly bring out your calculator. I'll be asking your participation. We have here an overhanging beam ABC, okay, in this figure, and it carries a concentrated load at point A with 200 pounds, no? And meron tayong uniform load here, or uniformly distributed load na 120 pounds per feet. Okay, so given naman yung dimension ng beam, so we have to, of course, draw the shear and moment diagram, and of course, determine what are the maximum values of shear and moment. Of course, those were important values for us to design our beam, no? So, again, what is our procedure? Of course, we need to compute the support reaction. Okay, for this one, Unahin muna natin yung equation method. No? Okay, equation method muna tayo. Okay, so this is, of course, B, vertical na, or B sub Y, no? Vertical reaction at reaction sa B, hinge yan, no? Kung may horizontal force, supposedly meron yung horizontal reaction. Okay, so this is a roller, so vertical reaction, C sub Y na lang. Now, let's compute for the support reaction. Support reactions. Okay, so summation ng moment, be it point B or C, either way, no, summation ng moment about point B na lang. Is equals to zero, of course, positive clockwise for our equilibrium equation, no? So that will be what? Negative, dito ko na lang lalagay, no? Negative 200 times, of course, the moment arm is 4 feet, negative, because counterclockwise about point B, di ba? So, what else? Negative CY then, no? Multiplied by the moment arm, 10 feet. And of course, the uniformly distributed load. No? Plus, of course, the area. No? Area lang yan ng ating uniform loading. So, that is 10 base 10 times, of course, the magnitude ito, which is 120 pounds per feet. Okay, that's only the magnitude of the force. No? Okay, when we take the single concentrated load, no, resultant ng 120 pounds per feet, and it will act at, of course, at the center of this figure, rectangle naman yan. So, yung moment arm natin will be what? 10 all over 2 or 5. No? So, that will be 10 all over 2 for the moment arm. Okay? So, again, itong area is the magnitude of this concentrated load, no? And this is the moment arm, no? Itong 10 all over 2. Location ng um, resultant nitong uniform load. Okay, so equals to 0. Can you give me the um, reaction, no, at support C? You can speak right away. Sige, ilan to?
5,
5,
520 po.
520 pounds. Okay, anyone? Parehas lang ba? So I can already take that para may verification lang tayo. Kasi pag nagkamali tayo ng isa dyan, uulit tayo lahat, no? Anyone? Parehas lang? I need the confirmation. Wala.
Parehas
So,
po.
okay, sige. Parehas lang din sa akin, no? Sige. Mag-solve din ako para ma-double check agad natin. Okay? So, now, summation ng this is, of course, the support reaction at C. Summation ng force vertical equals 0. Positive upward. So, what do we have here? We have By. We have computed Cy. So, going upward, 520 pounds. What else? Yung loading na 200, no, pounds at the end ng overhang. So, minus 200. Then, of course, minus itong area ng uniform loading, na, to get the magnitude. So, minus 10, base 10 times height of 120 is equal to 0. Okay, wala na, no? Isa, dalawa, tatlo, apat. Isa, dalawa, tatlo, apat. Okay, so what is our reaction here? By. Anyone, go ahead. You can speak right away. Na. Feel free to speak. Okay, once na I already asked you to participate. Ilan to? 880 pounds, parehas lang? Guys, parehas lang?
Yes po, sir.
Okay, so 880 pounds. Now, ano bang method tayo muna? Equation method muna. No? Okay, unahin natin equation method. Okay, so what is our procedure for the equation method? Diba? After computing the support reaction, we need to put, no, we need to indicate segments wherein nag-occur yung discontinuity ng ating loading. So with this one, diba, segment AB, okay, ito yung unang segment, then segment BC. No? With these segments, continuous yung loading, meaning ito lang yung nag-occur na loading. Okay, so with this one, okay, yun yung discontinuity na meron tayo or this particular segment. Okay, so segment A, B, and BC. With that class, we need to indicate a certain origin. Now, of course, ito yung y-axis, then this is x-axis. So this is our origin at point A. No? origin, lagay ko na lang, origin 0, 0. So, segment, no? Segment, pagpala dito, no? Dito na lang sa right side. Para dito tayo mag-drawing namin ng sure and moment. Okay? Segment, EB, okay, per hour beam. Ang ating limit, of course, ano yung value ng x? From 0 to 4, di ba? So, from 0 to 4, so yung ating limit for x values are ito, na, from 0 to 4. Now, of course, we need to introduce a cutting plane para makita natin yung mga shear and moment, no, internally sa beam. Okay, this is the cutting plane number 1 na lang. No? FBD, free body diagram for our cutting plane number 1. Okay, so ano makita natin? I-isolate natin yung left side, no, ng beam. So anong matitira dyan for segment AB? Ito yon, no? Then, of course, we have a 200 pounds load. Then, upon cutting, no, ano makikita nyo? Meron tayong shear and of course, meron tayong moment. Right? So, yung direction ng assumption dito is always yung positive sense natin, di ba? The positive sense is yung shear ay magpo-provide ng clockwise rotation and yung moment ay papangitiin yung beam or it will make the beam concave upward. No? So, yan, nangiti yung beam dyan with the moment. Assumption ng direction. Now, upon drawing the free body diagram, di ba? This is point A, this is B prime, that's prior point B. No? Take the equilibrium equation to come up with the shear and moment equation. So for the moment, di ba? Shear muna. Summation ng force vertical equals 0, positive upward. What do you see here, di ba? Ito lang naman yung 200 pounds force. Negative downward. And what else? Negative din yung V going downward. Is equals to, meron pa bang forces? Vertical, wala na, di ba? Equals 0. So the shear equation will be what? Transposing on the other side is negative 200 pounds. Okay, this is the shear equation for segment AB. Now, for the moment equation, of course, ganun pa rin. Using the equilibrium equation, summation moment naman. No? Summation moment about B prime naman. Okay, so about B prime, we forget to indicate the distance. Of course, we indicate distance x, no, on our free body diagram so that we are always referring to this origin, no? And we can come up with an equation representing shear and moment in terms of distance x from our origin. Okay, so that will be what? Summation moment about B prime. So counterclockwise, no? Itong 200 pero sige, summation moment about B prime is 0. Positive clockwise yung ating assumption ng direction. So negative 200. Of course, ito yung moment arm, itong distance x. What else? Meron pa bang forces? Wala na. So itong moment na lang na internally sa beam. That is what? Counterclockwise. So that is negative m is equal to 0. So we have our moment equation as what? Transpose lang natin yung m. M is equals to negative 200x. Okay? Now, these two equations here is only valid within these segments AB, wherein ang limit natin for value ng x is 0 to 4. Okay? So, if you substitute value ng x dito sa equation na to, it is only valid with the limit 0 to 4, indicating the segment AB. Okay? Now, for the next segment, of course, ano sunod na segment? Ito na yan, itong segment BC na. Okay? So, for the cutting plane, para makita natin yung internal reaction sa beam, which is moment and shear. Then, yan, yung cutting plane number 2. So, for segment, baba ko lang ng konti class na. For segment, or maybe ganito na lang. Ilipat ko na lang mamaya yung equation. Dito ko sulat muna. Okay, so, for segment, BC, okay, and our limit for x is of course 0 reference, no? 4 to 14. Okay, so this is 4 from 0 origin now to point B is a 4, and of course up to point C, that is what? 14. So that is why ang ating limit is 4 to 14 on our value of x. Okay, so 4 to 14 yan. And then, of course, the pre-body diagram. Pre-body diagram for the cutting plane segment at point 2. Okay, so we isolate the left portion, okay, for our pre-body diagram. So ano makikita ninyo? Of course, makikita nyo is that ito na, no? Okay, point A, point B. So buo yan. Then with a loading, concentrated loading at the end of 200 pounds. And of course, drawing natin until cutting plane. No? Ito yung cutting plane. So, ano makikita nyo dyan? Of course, shear internally and moment, di ba? So, and then, what else? In loading, di ba? We forgot. So, this is just before point C. So, ilagay natin C prime na lang to. Point C prime. So, syempre yung loading natin dito. Okay? So, okay, ilan yung magnitude? 120 pounds per feet. Okay, so again, define naman yung distance na to from point A to point B. Diba, this is 4 feet naman. 4 feet. Then, of course, yung reference natin at the origin going to the cutting plane is represented by x distance. Okay? Now, kung x distance yan, then itong distance between B to C prime or until sa cutting point is what? Kung 4 to, then x to. So, x minus 4 to. Right? So, yeah. Now, kung, again, x minus 4 yan kasi, di ba? This is x, then this is 4. So, x minus 4. Okay? Now, we are ready to solve ba? What do you think? May kulang tayo, no? You did not see this one. We need to include the support reaction. Okay? Kasi hindi magbabalance yung ating share and moment dyan. Kailangan kompleto lagi, no? So, be careful. Okay? What I'm trying to say is be careful with that. No? May malimutan nyo. So, we have here the support reaction of 880 pounds. So 200 pounds, 880 pounds reaction. Then the uniform loading got just prior point C, C prime, and then distance x represented by the distance, no, from the origin at point A to the cutting plane here. No? So, yan. With that, we can already come up with our shear and moment equation. No? For summation of force vertical equals 0, positive upward, we can get the shear equation. Okay? So, that will be what? Downward negative yung 200. No? So, negative 200. Going upward yung reaction na 880. And then, going downward itong 120 pounds per feet. Okay? So, minus, of course, area. No? Area ng ating uniform load. The area will be base times, of course, height, which is the magnitude ng uniformly distributed loading. Okay? So, that will be minus, yung base natin is of course x minus 4, di ba? So, x minus 4 times height, which is the magnitude na 120. Okay, meron pa ba? Summation forces. 200, positive 880. Then, the uniform loading. Of course, itong shear. No? So, going downward yung ating shear B. Shear force B. Okay, ito. Forget. So, minus B is equal to 0. Okay? Now, of course, we need to simplify our equation na para madali siyang magamit. So, transpose natin itong B. Okay? So, dito ko na ilagay sa left side. So, positive na yun. Okay? Is equal to this expression. Simplify natin. Negative 200 plus 880 is ilan yun? Positive 600. Positive 680. Right? Then, ito ay i-distribute natin. No? So, that will be what? So, negative, diba, 120 times x is 120x times negative. So, negative 120x. Okay? And then, 120 times negative 4 is negative 480. Tama ba? That's 480. So, negative 480. Mali. Negative 4 times 120 is negative 480 multiplied by negative sign. So, positive na yan. 480. Right? Then, Yan na yun. Then we need to simplify pa. No? So shear equation will be negative 120x. 680 plus 480 is ilan yan? 1160. Tama ba? Plus 1160. 80 plus 80 is 160. And then 600 plus 400 is 1,000. Tama. No? So this is the shear equation. Again, this is only valid with the limit na 4 to 14 yung value ng x since it represents segment BC. Okay? Now, for our moment equation, finally, no? For the moment equation, okay, taas ko lang alt muna to. Siyempre, summation ng moment naman, no? Summation ng moment about point B prime, C prime na pala to, no? In our cutting plane number 2. C prime is equal to 0, positive, clockwise. Okay, so anong meron tayo dyan? Of course, about C prime, of course, itong 200 pounds, ang moment arm is X, but negative yan, no? So, counterclockwise yan. So, negative 10, 200 times X. For the reaction 880, di ba? Moment about point C prime. Clockwise, so positive 880, but the moment arm is, of course, X minus 4. And then, what else? Itong uniformly distributed loading. Of course, may moment yan about point C prime. Okay? So, yung magnitude dyan is what? Area, of course. So, pero ang rotation yan will be what? Counter, clockwise. So, that is the area. Okay, the magnitude is in the area, of course. The area is X minus 4. Base times height, no? So, unahin natin yung 120, no? 120 times X minus 4. Minus 120 times X minus 4. Okay, now class, that is only the magnitude. Diba, if we are to represent a single resultant for this uniformly distributed loading, diba, mag-a-act yan sa centroid nitong figure na to. Okay, ng uniform loading. So, ang location ng resultant na yan, which is itong magnitude na to, 120 times X minus 4 will be at the center of this rectangle. And the center of the rectangle is ito yun, no? So, yung distance yan to our moment center, C prime is what? X minus 4 all over 2. Diba? Kalahati lang nitong X minus 4. So, X minus 4 all over 2. What else? Meron pa ba? Siyempre, itong moment variable na to. And the direction is counterclockwise. So, minus m on our equation equals 0. So, again, simplify lang natin. Transpose ko to sa kabila. So, dali ko na lang sa left side. No? M is equals to, anong meron? No? Negative 200x. Tapos, distribute natin plus 880x minus 880 times 4. Ilan yan? 880 times 4. 3520. Okay, class, paki-check tong mga calculation ko para tuloy-tuloy tayo. Okay, pagka merong na tayo po, kindly let me know. No? So, negative. Then, how about this one? Pag sinimplify natin yan, ito ay 120 all over 2, magiging minus 60 na yan, di ba? So, itong dalawa is of course x minus 4 squared na. Okay? Now, simplify pa natin, no? Itong equation. Okay, let me zoom this in a little bit. So, to simplify this one, negative 200 plus 880x, ilan yan? So, 680 na positive. 680x minus 3520. Now, class, ito, di ba pa natin i-direct na ito, no? Or sige, huwag natin i-direct na. This is simply what? Square of difference nitong dalawa, no? So, ang ginagawa dyan, pwede rin FOIL method, is up to you, pero ganito yan, no? Square natin itong first variable here. So, x squared, of course, minus, that will be 2 times x times 4. So, ilan yan? 2 times 4, 8 times x, so 8x. But take the negative side. So, x squared minus 8x, di ba? So, 4 times 2, 8. So, negative 8x. So, then, of course, lastly, square natin itong last term here. So, that will be square ng negative 4. Di ba? That is positive 16. Okay? Meron pa ba? Wala na. No? So, i-simplify pa natin. So, that will be um, negative 60x squared, lagay ko na dito, no? Then, 680x plus, of course, di ba, ano to? Di ba, 60 times 8, ilan yan? 60 times 8 is 480. So, negative times negative is positive. So, positive 480x yun. Right? And then we have to add 680. So, 480 plus 680, that will be positive 1160x. Okay? And then, ano pang matitira? Itong constant, no? Itong negative 3520 with this one, no? Pero kung mapapansin nyo, negative and positive. So, negative, ano yan, ang value, no? So, negative 60 times 16, ilan yun? Negative 60 times 16. That is negative 960. Okay? And then, plus negative 3520. So, 3520 will be negative 480 for the constant. Again, simplification lang to, no? Algebra lang to, class. Pag kayo nalito pa dito, ewan ko na lang, dapat ito yung mas kanina. Negative 3520 minus 60 times 16 is 4480. So let me check 60 times 16. 960. Okay, tama naman. So minus 4480. So this is the simplified moment equation for segment BC. Now we are already complete with our equation. So we are ready to draw the shear and moment diagram, and later we can already come up with the value ng shear and moment ng shear and maximum moment. Okay, so ilipat ko lang ito, class. Okay, before we continue on our solution, i-arrange ko lang para mamaya I can send this one to you, no? Sa as your notes, no? Or meeting notes. And the typical thing that I do, no? Para ma-review yung additional reviewer somehow. Okay, so we are ready to draw the shear and moment diagram. No? So, paano ba to? Diba, using the equation, we can already draw the shear and moment diagram. Okay, so class, are you with me with this procedure already to draw the shear and moment diagram? Anyone? Can you confirm? Class, can you confirm?
Yes po.
Okay, so sige, how do we do, di ba? Of course, i-drop down lang natin with some lines, no? On each segment points. Okay, so yan. Then the horizontal line here means our reference datum for our value of 0. So for the first diagram is shear and our unit is pounds. Okay. Now, okay, using this equation, no, anong nakikita nyo? We have a negative 200 pounds. Meaning, class, di ba? Wala naman tayong x sa ating equation. So meaning that is already negative 200 here. No? So going downward, that is negative 200. Now, this is, ang tawag dito, this is applicable, no, for our limit, no, from 0 to 4, or meaning from this segment. Okay, so until point B, but prior to this loading reaction of 880 pounds. Okay, so meaning continuous lang yan na negative 200 pounds for the shear. Okay, for this segment AB. Now, of course, we have to continue. No, so from there, we have an equation here, an initial equation that is negative 120x plus 1160. Okay, so isulat ko lang dito, no, for segment BC, ang ating shear equation is negative 120x plus 1160. Okay, now class, ano yung limit natin for segment BC? That is 4 to 14, right? From 4 to 14. So, kapag sinabshoot nyo yung value ng x, Okay? If x is equal to 4, then it will give you the value here ng shear. Okay? So, ano yun? That will be what? V is equal to negative 120 times 4. Okay? Plus 1160. Ilan to class? So, negative 120 times 4. Okay, negative 120x na lang. Plus 1160. Then, calc. Bigay ko ng value 4. That is 680. Okay? So, meaning, um, at point B, no, already, okay, at x is equal to 4, that will be what? Positive 680 na yung shear. Okay, so positive 680. So positive 200 dyan. So approximately ito na lang yung 680. So 680 na yung ating shear. So going upward here. And then, of course, if value ng x is 14, then the shear value will be what? Okay, hindi ko na use that class. That will be negative 120 times 14 plus 1160. So, calc lang ulit ako no, for our equation with value 14. Ilan to class? Anyone? So nga, here is what? If x is equal to 14 from the shear equation. Go ahead. Ilan? Ilan yung shear?
Sir, negative 520 po.
Okay, correct. No, so negative point 520. Correct. So now class, this is negative 520. Let's say this is approximately no. So negative 520. Now, okay, connect lang natin. But of course, discuss ko na ba sa inyo yung degree ng curve? Tama ba? Na-discuss ko sa inyo last time. Nung nag-moment area tayo, tama. Nag-area tayo, area method last time nung malapit na matapos ang oras. I think naalala niyo yun. No? From 0 degree, this will be a first degree curve or simply linear lang yan or tuwid lang. Okay? So, connect nyo lang no? Yung value 680 and negative 520. And then, of course, kung mapapansin nyo, we have a reaction here that will bring back this shear equation to 0. But basically, if you will yes, tama naman. No? So, with that, if x is equal to 14, then that will be negative 520. And then with the reaction, it will bring back our value to 0. So, this will be our shear equation. Now, take note, di ba, laging bumabalik yan sa 0 since they should be in equilibrium. No? Kasi pag meron ba tayong structure na gumagalaw, di ba? Sasaya yung structure, hindi naman, di ba? So, yan. That is only for the shear equation, shear diagram. And then, for the moment diagram, of course, ano yung mangyayari na? Okay, i-drop down na ulit natin yung mga segment no, that we have. So, okay, drop down lang natin. As you can see, meron tayo ditong zero shear. Okay? So, we need to drop down here. No? Since yan ay magiging bagong segment on our moment diagram. Okay? And class, kindly store this one on your concepts. No? Ito, no? With, the maximum moment will occur at zero shear. No? So makikita niyo mamaya class at this particular section ng beam na dito mag-occur yung maximum moment. No? Again, zero shear, at zero shear, the maximum moment will occur. Okay, so, but of course, we need to know what is this distance. No? Hindi natin alam to. Okay, so alamin natin to paano ba ito makukuha. Of course, using similar triangle, okay, method, no? Or applying similar triangle theorem. So, kung x yan, we assign this one as x. Ito in total ay 10. So, itong pambilang side ay 10 minus x. Okay? So, how can we solve this one? Okay? Applying, saan natin ilalagay yung solution? Masyadong malayo na. So, sige, dito na lang sa baba. Then, ilipat ko na lang. Solving for x. Okay, similar triangle lang. That will be what? 680. 680 all over x. No? Again, 680. This is the side. Then this is x is equal to 520 all over. This is what? This one is 10 minus x. And last, pakiship solve na nito. Anong value ng x? X is equal to
5.67.
5. Can you give me 3 decimal place? 5.67.
667.
5.667. Okay, how about the others? I need at least another confirmation para lang for checking.
Same
Pares
sir,
lang.
same.
Okay, so good. Now, after solving distance for x, then we are already ready to apply, no, or use the moment equation. Okay, so ibaba ko lang dito muna. Mamaya ko na lang i-start yung solution. Okay, ano yung moment equation for segment AB muna? So, unahin natin tong segment na to. Okay? For the moment diagram, again, let's draw a horizontal line for the datum value of 0. So, this is moment diagram. The unit is pounds feet, right? Now, do we have a moment loading here? Kung merong moment loading niya, let's say clockwise 20 pounds per feet. So, positive yun ang drawing natin pataas, di ba? 20 pounds per feet. Wala naman tayong loading or any reaction, so wala. Okay? Now, mag-refer lang tayo sa ating equation. So, ano equation? Negative 200x. Now, class, for segment AB, kung yung value ng 200 is 0, syempre, di ba yung limit is 0 to 4. If x is 0, di ba, negative 200 times 0 is 0. So, 0 lang yan. Okay, lagay lang natin dito 0. Then, of course, if x is equal to 4, then that will be what? Negative 200 times 4 is negative 80. So, negative 800 rather, no? So, negative 200 times 4 is negative 800. Negative 800, okay, ibaba natin dito. Okay, so let's say this is negative 800 na lang. Now, 0 degree, of course, first degree yung verb natin, tuwid lang, no? So, again, that's 1 lang lagi, no? So, kung 0 degree yan, that's 1, so first degree ito sa baba. Okay? And then, this is for this segment. Now, for the equation ng moment, rather, no? For segment BC, that is negative 60x squared plus 1,160x minus 4,480. So, for this moment equation, no? Pakisolve class, no? Type nyo sa calculator itong negative 60x squared. So, negative 60x squared, type nyo, no? Negative 60x squared plus 1160x minus 4480. Okay, huwag nyo lagyan ng equal 0. Then, calc na lang. If ang value niyan ay, of course, yung limit natin na una is 4, no? Ano yung value ng moment kapag yung value ng x is 4? Okay, ano yung sagot? Can you give me a? That should be negative 800, no? Kasi negative 800 yan dun initially, no? Wala naman tayong moment load here. Negative 800 ba yung lumabas sa inyo sa calculator? Plus?
Yes, sir, same po.
Okay, same. Now, using again the moment equation, okay, kapag ang value ng x natin is, of course, meron tayong segment here na naputol. If ang value ng x is 5.667, sige nga, pakicompute kung ano yung value ng moment. Sige, let me write the solution. Or wag na, I think susundan naman. Let's use the equation here since we are dealing with equation.
166.
Okay, ilan yan? If x is 5.667 using this equation, ilan yung moment?
166.827.
Okay, 166.827. Positive, no? So, positive 100 kung 800 yan. Approximately, ito na lang yung 100 plus, no? So, positive 166 point 827, tama na? 827? Okay. So, now, paano natin drawing to? Di ba? We have a first degree curve here. Plus. So, kung first degree curve na yan, ano yung degree ng curve dito? Plus 1 lang, di ba? So, second degree curve. So, you're expecting na may curvature na yan. Since second degree curve na yan. And it's a parabola. Okay, with that, let me introduce to you this one for your guide. Kasi hindi mo alam, di ba? Pag ganun ba yung curve or pag ganun or pag ganun? Okay? Concave upward ba yan or concave downward? No? So, you don't know. So, ito yun, no? Naturo ko na ba sa inyo ito? Hindi pa ata, no? Ito yung ating guide in drawing our sharing moment diagram. Okay? Ito yung BD na tinatawag mo. So, sino ang nakakaalam ng kung paano gamitin yung DD na to? No? D, D. Okay? So, what DD? Ito yan, no? Decreasing, increasing. Decreasing, increasing. Okay? Positive, negative, negative, positive. Okay? Kindly listen with this one, no? Kasi ito yung importante on your concepts for drawing the sharing moment diagram. Okay? Ito yung guide natin. So, class, titignan nyo lang, no? With your diagram ng ating shear, okay, yung area na to. Kung mapapansin nyo, class, from this segment, no? Kasi ito yung ating drawing, no? Okay? Yung ating shear is nag-decrease na from 680 to here. Bumaba, so decreasing siya. Now, so decreasing now. Either yung drawing natin is pag ganon or pag ganito. Okay, ano yung positive, negative? This means, kapag yung graph natin is above the datum, positive yan, di ba? Pag nasa baba, negative. So, meaning this is decreasing positively. So, decreasing positively, meaning ito yung ating magiging graph, no? When we connect the values ng ating moment. So, pag ganun. So, with this one, connect ko siya ng ganun. Okay? Kuha ba ito, class? Can I have a confirmation with this one? Nakuha ba? Anyone?
Pwede pa ulit, sir.
Okay, sige. That's good. You ask me once again. No? So, again, if we, di ba kanina, balikan ko lang. Hindi natin alam kung ito ay, we already know na hindi na yan straight line, di ba? Kasi nga, first degree na to. So, dito you're expecting a second degree curve. Since kung first degree, mag-a-add lang tayo ng 1, magiging second degree na yung curve. So, meaning may curvature na. Now, we don't know kung pag ganun yan or pag ganun, di ba? Okay, or pag ganun yung graph. Or maybe pa lang to when we connect the values. So, para makuha natin yan, ito yung guide, no? Ito yung reference. I-box ko lang, no? Itong BD, no? So, D is increasing, D is decreasing, I is increasing. Now, mag-refer kayo sa shear diagram for the drawing of moment diagram. For the shear diagram, di ba? Ano meron tayo dito for this segment? Itong area na to. And what we have here is a decreasing value ng shear. So, from 680 diba to 0, decreasing yan. Okay, so meaning decreasing. Okay, ito lang yung magiging graph natin. Either these two. Okay. But, of course, nasa above yan ng datum natin. That is why positive yan. No? So, meaning decreasing positively. So, decreasing positively. Okay, so ito yung ating guide. No? Hindi ito. Okay, so ito yun. Okay, so when I connect the values, ito yan. Kuha ba? Doon sa nagtanong, okay na?
Yes po, sir. Thank you.
Okay. Sige. Now, after that, syempre, this is only the value ng moment when ang value ng x is 5.667, right? Now, again, using the equation here, no, the moment equation, negative 60x squared plus 116x minus 4480. If ang value ng x ay yung huling limit natin, yung 14, to finally close this moment diagram, na pakilagay niya kung ang x is 14, anong sagot?
Zero.
Okay, yes, that should be 0, no? So, kapag hindi nag-0 yun, so meaning may mali sa inyong equation. Right? So, Okay? Hindi siya solve, no? Calc lang. Okay? So, calc 14, that is 0, right? Ayan, magiging 0 na yan. So, from 166.827 to 0. Now, class, again, how do we know kung yung ating graph is pa ganun ba yun or pa ganun when we connect the value? Okay, again, refer lang kayo sa ating shear diagram. Okay? Ano meron tayo? From this segment, for this segment, no? From left to right, that is what? From 0 to this value, not tumaas yan. So, meaning it increases. But, this time around, negatively kasi nasa ilalim yan ng ating horizontal day 2 reference. So, this will be increasing but negatively. So, increasing negatively. Okay? Increasing negatively. So, ito yan. Okay? You connect this values na ganda. Okay? So, I think clear na yan with that, no? So, huwag nyo kakalimutan yung DD, no? Sinong magaling makaalala niya, no? Ewan ko na pag nalimutan nyo pa yan, no? Madali lang naman sundan. Okay? Now, from our shear and moment diagram, then, anong meron na dito? Diba? We can get maximum moment already and the maximum shear. Okay? Therefore, Mmax, maximum moment, anong maximum moment? Anyone? From the graph.
166.827.
Are you sure? Meron tayong dalawang point where nag-occur yung zero shear. Okay, may zero shear tayo dito, may zero shear tayo dito. So, alin dyan yung maximum moment? Are you seeing this value? Mas malaki ang 800 sa 166, di ba? This is negative. Okay, don't forget to include the side. Okay? So, negative, meaning, anong mangyayari, di ba? Papangitin yun yung beam. Or in that case, magko-compress yung taas kung yun concrete and then yung sa bottom part is of course component yan, no? For our concrete beam in that case. Okay? So, negative 800 pound speed. Kuha ba ito, class? Okay? So, tingnan nyo lang kung ano yung maximum value, be it positive or negative. But don't forget to include the side. Okay? For the maximum shear, of course, refer lang kayo sa diagram. Then, ano yung maximum value dyan? Then, that's it. No? Ano yung maximum value? Anyone? Ilan? Positive?
Yung
680.
680, sir.
Okay. Correct na. So, positive 680 pounds. Okay, so ito yung ating maximum values ng shear and moment. Okay, negative 800 pounds and pound speed and um, positive 680. Okay, let's check on our module. No? In case na may mag-review sa module, okay, I just want to reiterate this one. Nasa na ba yun? Okay, if you will be reviewing on your module, okay, ito yun, no? Saan na ba yun? Yes, ito yun, no? So, ito yung ating parehas lang, no, with our computation, kung mapapansin nyo. Okay? Ito ba yun? Wait. Yes, ito. But what happened? Negative 800. Class, may mali ba ako na-isulat kanina with our... Tama ba yung nasulat ko dito? Can you check? Sa dinectate ninyo? Using the shear equation, the moment equation. Double check niya. Kapag ang value ng x is, ang tawag dito, what did I told you? Ang value ng x is 5.667 or supposedly dapat yun ay 9.667. Ano sinabi ko kanina? Plus, what did I told you kanina?
5.667.
Okay, so that is our error, no? Okay, my bad. Okay, kasi ang reference natin ng equation here, okay, ang reference natin ng 0 is from point A. So we all know this value of x is 5.667. So we need to add 4 here so that yung ating value ng x should be coming always from 0 origin. Okay? So again, pakicompute niya. Numberin ko lang ito. Hindi na magiging skill pala yung ating graph. Okay, my bad. Pakisolve nga class kapag using this moment equation. Okay? Ano yung value niyan kapag yung x is 9.667? Kumain, may graph tuloy na.
1126.67.
1126.
667.
Okay. 1126. 1126 point. Go ahead.
666. Ay, 667.
667. So the maximum moment, yan, this time around, dito nag-occur maximum moment. Pero kung mapapansin nyo, dun nag-occur yung mga maximum values wherein the a point wherein mag-zero yung shear. No? So with this one, ang ating maximum moment is this value. Okay, 1126.667. Okay? So, on our computation, hindi tayo nag-round up, no? Sa mga modules kasi, ano yung modules na masyadong mataas yung round up. Okay? So, hindi ganito conservative yung computation. Okay, again tayo ay 3 decimal places lagi. No? Pag, on our method. Okay, again class, yung x distance here being used for our moment equation is 9.667 since ang reference natin lagi is from the 00 origin. So 9.667 yung ginamit here, no? For to the substituted sa moment equation to get 1126.667. And kanina, di ba, ginamit naman natin 14 kanina, ano, the equation, that is why bumalik yan sa 0. Okay, so this is the shear and moment equation. And those were the maximum values of moment and shear. Okay, so ito, no, pinakita ko to kanina. Then, ano ba yung gusto kong i-emphasize dito? On the equation ng, ang tawag dito? On the solution ng ating module, nag-iiba tayo ng computation. No? Hindi naman nag-iiba ng equation. It so happened that using the equilibrium equation, ang assumption niya is counterclockwise positive, but tayo is clockwise. Pero kung mapapansin nyo class, babalik tayo sa isang equation. I-compare natin. Ito yung kanyang method, counterclockwise positive. Okay? Ito yung moment equation. Puntahan natin sa ginawa ko. The moment equation is similar pa rin. Either you assume na on your equilibrium equation na ang summation ng moment is positive clockwise or positive counterclockwise. You will come up with the same moment and shear equation. Okay? For the shear equation naman pala, parehas lang naman na positive upward yung positive direction. So, yun lang naman na gusto ko i-emphasize doon. Pero that is our method. Now, let's do the much easier method for drawing the shear and moment diagram for the beam. Okay, so that is the area method. Okay, mas mabilis lang ito, no? Sige, bilisan natin yung pag-solve mo ito. Area method. Pagkain ko na lang plus yung ano, no? Yung reaction since na-solve naman natin kanina na. Okay, so that will be 880 and 520 pounds. 880 and 520 pounds. Okay, so now upon solving the reaction, di ba? Then you can already go to proceed with drawing the shear and moment diagram. Okay, ito yung paborito ng lahat, no? Kahit ako din nung nag-aaral ako, paborito ko to. Ang base kasi, no? Pero syempre, you need to know all the method kasi may mga advantages and disadvantages yan depending on the question. Okay, so of course, paano ito din ang drawing? Diba? So, 200 pounds means downward, no? The drawing lang natin. Sundan lang natin yan. So, 200 pounds downward, so negative 200. Okay? Then, wala naman tayong other loading here. So, continuous yan until just prior point B. Okay? Now, again, negative 200 pa rin tayo dito. Then, meron tayong force upward for the reaction. So, negative 200 plus 880, that is positive 680. Diba? So, tataas tayo dito ng positive 680. Bilis, no? Then, now, positive 680 minus 10 times 120. Ilan din class? 680 minus 10 times 120. Ilan yun? Can you give me? Anyone? 680 minus 10 times 120.
Negative 520, sir.
Okay, negative 520. So, approximately ito, let's say, negative 520. Again, this is the shear diagram, unit is pounds. So, kung negative 520, again, 0 degree curve to, di ba? 0 degree curve. So, this is first degree. So, straight lang tayo dito. Okay? When we connect the value. Okay? So, negative 520, then of course, we have a reaction going upward, positive. So, negative 520 plus 520. Okay? Babalik yan sa 0. Okay? So, this is our shear diagram. Bilis, no? Plus, mukha lang tong matagal yung kanina dun sa equation method kasi nagdi-discuss ako. No? Then, I'm addressing your questions. Pero kung yan ay nagpo-solve na kayo on paper, then tuloy-tuloy naman, madali na either method. Pero definitely, mas mabilis ng content. Itong um, area method. Tama ba area method yung nilagay ko? Okay, so now let's continue, di ba? For the moment diagram, tuloy lang natin. So, drawing ulit tayo ng mga boundary line on our graph. Okay, so again, this is for the moment diagram. So M, this is, the unit is pounds, feet, height. And again, reference natin for the horizontal datum is 0. Okay, so now, wala naman tayong other loading, moment loading wala naman. So wala tayong magiging addition per segment. Okay, for boundaries. So we need the areas lang. Okay, so let's say area 1 to area 2. Then this is area number 3. Okay, kumpitan natin yung mga area and okay, areas. So area 1, area 1 na lang. Anong area yan? Area 1 is equal to what? Base times height. So, base times height, ano ba yung base natin dito? 4 feet naman yung dimension yan. So, 4 times 200. Okay, ilagay ko na yung sign no, para tuloy-tuloy yung tayo nag-add mamaya. So, A1 is simply 200 times 4, that's 800. So, negative. And area number 2. Kasi di ko na i-solve ulit ito. Di ba yung distance na to? Na-compute naman natin kanina. By applying similar triangle. That is 9 points, no. X computed kanina for this one is 5.667, tama. So, 5.667, tama ba? Yes. 5.667. Balikan ko lang class, no? Okay, so, again, let's pick this view. Ang hirap mag-set ng screen view dito sa online class. No? So, 5.667. Itong kabila, ilan to? Siyempre, 10 minus 5.667. That is 4.333. 4.333. Now, for area 2, itong triangle, positive na. 1/2 base 5.667 times the height ng magnitude na 680. Ilan to class? Anyone? For area 2. Nang pakibigyan na lang. 1, alin?
Yung area 2 po ba?
Area 2.
1126.78 po lumalabas.
1126 point.
Ay! Hindi sir, wait lang po. Minus ko na pala agad. 1926.78.
1926.78. Okay lang na.
78.
Now, for area 3. Ang ginawa niya is kinocompute niya na ng tuloy-tuloy na. So, medyo advanced na yung nagpa-participate. Sino nagpa-participate na? That's good for you. For area 3, ano tong area 3? 1/2. But of course, negative na. Negative 1/2 base ng 4.333. 333 times, of course, height 520. Ilan tayo dito for area 3? Negative yan, so negative sign. Go ahead. Ilan to? Anyone? One, 26.
0.58, sir.
Negative, yes, correct, no? Negative 1126.58. Correct, no? So again, these are the areas na kailangan natin in order to completely draw the moment diagram. Okay? So, paano yan, di ba? Again, check nyo muna kung meron tayong mga loading na moment. Kasi kung may loading, doon yung mag-define. Di ba? Let's say, for example, again, meron tayong counterclockwise na 20 pound speed na moment. Then ano mangyari? Negative on our equilibrium equation is counterclockwise, di ba? Counterclockwise negative. So meaning, pag nag-draw kayo ng equation, anong moment diagram, meron muna dito negative 20 pounds per feet. Then tsaka nyo ulit i-consider itong area. So let's say, nakuha nyo ay yung value ng negative nyo ulit. So ganun. Ganun yan. Okay, but initially wala naman tayo moment values dyan. Okay, so magsisimula tayo sa 0. Okay, so with that, we take the area 1. So that will be negative 800. So from 0 to negative 800. Okay, so negative 800. 0 to negative 800. And again, 0 degree curve yung taas. So first degree curve pa lang to. So wait lang. And then negative 800 plus, no? We will add, no? Negative 800 plus 1926.78. Ilan yan? Ilan yung class? Negative 800 plus 1926.78.
Sir, 1126.78.
1126.78.
78 po.
Okay, so 1126, 1126.78. Okay? Again, di ba? Alam naman natin na ito yung i-connect natin, di ba? That is what? Decreasing positively. So ito yung ating pag-connect, di ba? So balikan lang natin. Positively decreasing. So that's how we connect the values. And of course, finally, 1126.78 minus 1126.58, meron tayong konting discrepancy. Okay? So, but it will go back to approximately 0. No? 4.333 times 520. So, meron tayong discrepancy na. So, that's on the rounding up. No? So, pero close to 0, approximately 0. Okay, don't worry as long as tama yung procedure na computation. No? I'm also considering no, yung mga minimal discrepancy pagdating ng final closing ng inyong shear and moment diagram. Okay, so this is the shear and moment diagram. Then we can already finalize. No? Therefore, the maximum moment is 1126.78 pound speed, and the maximum shear is positive 680 pounds. Okay, so I guess same lang ng ating shear and moment diagram, no? Same result. Okay, with different method. Okay, so happened that naka-equation kasi tayo dito. So somehow merong magiging variances talaga in our computation. Pero sobrang close yan. Sobrang malapit. Okay, so let me just put a first degree curve and a second degree curve here. So again, nadadagdagan ng class na from the loading 0 degree plus 1, magiging first degree sa shear, then magiging second degree sa ating moment diagram. Okay, so that's it for our first example. And okay, I'm thinking if we need to show this one to you, or we need to solve this one in detail. Okay, okay, pwede natin skip dito yung equation method, I guess. Then we will proceed with this one for both equation and area method para meron tayong mga ganitong example for you. No, kasi yun lang naman yung mga complicated um, loadings, no? Sige, what do we do? Okay, sige, gawin natin, kasi meron naman to sa module new class, no? I-discuss ko na lang muna equation method here. Nasa mo yan? Okay, then we do the area method, okay? For that example. Para makapag-moving load agad tayo, no? Yan. Class, are you with me with this one? No? Itong sample 4.4. Okay nga. Class, are you with me with sample problem 4.4 already?
Yes po.
Yes, sir.
Okay, so what do we have here is a cantilever beam. So meaning, kung cantilever yan, okay, free lang yan sa end, na walang support yan, and meron naka-fixed support yan. So when we say fixed support or rigid support sa end, meron tayong three reaction: vertical reaction, supposedly horizontal reaction kung merong horizontal forces, and meron tayong moment. Okay? Itong force na itong 1,000 pounds, hindi yan reaction lang, yan ay additional loading. No? May additional unit load sa end ng beam or sa free end ng cantilever beam. Okay? Now, it carries a triangular load with a magnitude of varying from 0 no, to 360 pounds per feet. Okay? So, and again, in addition, merong 100 pounds vertical load no, at the free end of the beam. So, we need to derive the shear force and bending moment equation, and we draw the shear force and bending moment diagram. Okay, neglecting the weight of the beam. So, now, kung may weight yung beam, di ba? Ano magiging loading nun? Uniformly distributed load na rectangular. No? So, pero in this case, wala namang binanggit no? Na weight ng beam. Okay, so with that, i-discuss ko lang mabilisan to for the equation method, and then solve natin using area method. Okay, so again, what we need to do is, of course, compute for the reaction here, no? Sa support. So, ito naman ay loading. So, this is the support reaction. No? Ano meron? Reaction vertical and yung moment reaction at the end. No? So, class, masasolve nyo naman to using equilibrium equation, di ba? Summation moment, no? And summation forces vertical. We get to compute reactions here, and then after you do that, then proceed with the method ng equation method. Ano ginagawa? We are to impose segments. No? So, ito naman, hindi natin kailangan mag-segment na kasi with this span, continuous naman yung loading na ito lang yung loading natin or walang discontinuity. Okay? So, yan pa rin yung makikita natin within AB. Okay? So, hindi na tayo magkakaroon ng additional segment pa. So, with that, di ba, para makita natin yung moment and shear, magka-cutting plane tayo. Okay? But on your module, ang cutting plane yan ay masyadong malapit. No? Or anywhere siya nagka-cut. Pero typically, ako ay nagka-cut just prior dun sa dulong-dulo no, ng segment. Okay? Sa kanya, nag-cut pa rin siya with this one, malapit lang. Pero parehas lang naman yan, di ba? When you cut here, yun naman yung loading na meron tayo. Parehas pa rin yung magkakamot tayo ng equation. So with this one, cutting plane 1, ano makikita natin? Again, same lang naman, di ba? The shear and the moment. Okay, so the shear is on the positive direction and the moment is on the positive direction. Nangingiti yung beam. Okay, so class, ang tawag dito? How do we come up with the equation? Diba? Siyempre, after getting upon cutting plane, makita natin yung shear and moment. So we need to represent the distance from the origin to the cutting plane, distance x. Okay? So, ngayon class, with this triangular loading no, from 0 to this point, hindi natin alam no, kung ano ba itong magnitude na to. Diba? Kasi we all know ito ay 360 pounds per feet. But saan ba nanggagaling itong uniform loading na equation na to with 30x no, pounds per feet? Saan nanggaling yan? Okay, ito na lang ipapakita ko sa inyo kung saan nanggaling yan. Okay, so ito siya class. No? Ito na lang. Okay, upon cutting plane, di ba? Let's say yung cutting plane kanina. Okay. Of course, makikita nyo is shear and moment. Okay, now distance x. Now class, at this point, di ba hindi natin alam yung magnitude ng uniform loading. So we represent this one as, let's say, y na lang. No? So using, of course, similar triangle, di ba? Makukuha natin yun, di ba? We can relate that in terms of distance x. So that will be what? Yung kabuuan triangular loading, that is 360 divided by the side here, the distance is 12, is equals to y, no? Yun yung magnitude ng uniform loading here at this cutting plane all over x. Okay, so meaning what you will be getting is y is equals to 360 all over 12 x. So 360 all over 12, ilan yan? That is 30 now. That is why, kung makikita ninyo, yung magnitude nun is 30x kanina. Okay, or simply ito na yung uniform loading magnitude at this point, no? In terms of equation 30x. Okay, so going back here on the solution sa inyong module. No? Okay, 30x siya makikita nyo. No? Okay? And plus, syempre, if you are to represent a single unit load for this triangle, di ba? Area lang naman yun no? Ng triangular loading, that is 1/2 base x times this magnitude. No? So 1/2 x times 30x, it will give you what? 1/2 ng 30x, that is 15x times x, so x squared. No? So 15x squared yung single unit load na yun. And it is acting, of course, at the center of the triangle. So which is x over 3 on this side and 2/3 ng x naman on this left side. Okay, but since we are taking a moment here, then ito yung kukunin natin ng moment r. Okay, so after that class, you will be coming up on this okay, equation for shear and moment. No? Isa lang yan kasi isang segment lang. Okay, so for the shear, nag-sum up lang, no? 1,000 yung end load, yung load sa dulo, no? Okay, and also this unit load here, no? Yung resultant ng triangular loading. Okay, and what else? For the moment equation, no? Take na kayo ng moment, no? At point, at this point, yung cutting point. So 1,000x yun, and then 15x squared multiplied by x all over 3. So simplifying those equation, makukuha nyo pa rin yung moment equation na to. And again, same method lang. No? To draw the moment diagram, then apply nyo lang yung ginawa natin kanina. Okay? Magbigay kayo ng value ng x on our shear and moment equation. And until maplot ninyo yung complete diagram. Okay? So, the difference is that, class, dito yung solution na you just need to review. Okay? The difference lang on this method is that yung moment equation is positive counterclockwise on the equilibrium equation sa module. No? Pero sa atin is positive clockwise. But still, that will yield to same shear and moment equation naman. Okay, so i-recheck natin itong value na itong graph na to and yung mga values using area method naman. Okay, so yun na lang yung solve natin. Okay, with this one. Now, burahin na natin to. Dito na lang mag-drawing sa kabila. Okay, applying area method now for this problem. Class, are you with me with this sample problem 4.4 using area method naman?
Yes po.
Okay, so don't worry, I'll be sending you yung mga presentation here and I'll be compiling yung ating mga module. No? So somehow we can have a single file for this topic. Okay, so area method, again, with the rigid support or fixed support at the end. Okay, anong reaction na meron tayo? A vertical reaction, may horizontal reaction yan supposedly, pero zero yan since walang force horizontal. So B sub y lang to. And of course, we have a moment reaction at the end support. So again, assume direction lang to. Okay, so M sub B. Now, let's compute, no? Support reaction. Okay, summation ng forces vertical equals 0, positive going upward. So that will be By, okay, plus itong loading na upward 1,000 pounds minus, of course, okay, itong triangular load. So the magnitude, the single unit load will act at this, approximately at this point, no, sa center ng triangle. But yung magnitude nito is, of course, the area, which is minus 1/2 times base 12 times 360. Again, this is just the magnitude. With this one, yung area, we need to multiply by, okay, we're taking summation of forces pala. Natin kailangan ng momentum. So summation of forces, By plus 1,000 minus 1/2 times 12 times 360. Okay, is equal to 0. So By is equal to, ilan to class? Go ahead, kung may na-complete na. No? Ilan to? Anyone? Go ahead, ilan?
1160.
1160. Okay, so Py is 1160. And then, of course, ano yung unit natin dito? Pounds and feet, so pounds. And then summation ng moment, okay? About point B is equal to 0, positive clockwise. Okay, so anong meron? Summation moment about point B, mawawala yung moment effect nitong By. Okay, so anong meron? 1,000 pounds going clockwise, so positive, the moment arm is 12. And minus, of course, itong triangular loading. So ito yung magnitude niyan, di ba? Yung area, which is minus 1/2 times 12 times 360. Then, of course, the moment arm. Okay, the moment arm of this magnitude ng triangular loading is, of course, 1/3 ng 12. Okay? So, centroid lang yan. Once again, 1/3 ng 12. Okay, what else? Meron pa ba? Of course, itong moment sub B, no? Itong unknown support reaction, no? Na moment at point B. So, counterclockwise yan. So, on our moment equation assumption ng direction, that's negative. Okay, so can you give me yung moment value, no? Reaction at end support. 1,000 times 12 minus 1/2. Go ahead kung meron na, no? Let's speak right away. Are you getting 3,360? Plus pound speed. Parehas lang? Yes, parehas lang. 360 pound speed. Same?
Yes, sir.
Okay. So, now, with this one, we are ready to compute for the, to draw the shear and moment diagram using area method. Okay, with that, paano ba yun? So, isa lang naman yung continuous naman yung loading natin at this span. No? So, natin mag-increase ng segment for the discontinuity. So, drop down lang natin yung span. Okay, then again, this is for the shear. Unit is pounds. Okay, 0 for our reference datum. Now, do we have any shear here? Or any force? Meron, di ba? 1,000 pounds. Okay, so going upward. This is 1,000. And of course, itong area ng triangle. Okay, yung area ng triangle. So, ilan yung class? 1,000, of course, downward to sa loading, minus yan, di ba, sa ating loading. So, 1,000 minus 1/2, 12 times 360, ilan yan? 1,000 minus 1/2, 12 times 360. Ilan yung class? Anyone, ilan?
Negative 1160, sir.
Okay, negative 160, correct na. So, negative 1160. And of course, babalik yun sa 1160, sa 0, no? Negative 1160 plus going upward to, no? 1160, so it will return to 0. Now, how do we connect this value. Di ba? Again, refer tayo kay DD. No? DI or DI na lang. No? DI. No? So, positive, negative, negative, positive. Lutuin natin. No? DD talaga yun. Baka malito pa kayo. No? So, um, with that, anong drawing natin? Di ba? What we have here is, for the loading, again, when we refer to the loading, hindi tayo nag-refer kung nasa taas o nasa baba. Okay? Nag-refer tayo sa direction ng load. So, ang direction ng load is negative downward, di ba? So, downward means negative for the loading. Take note, loading lang, we are not referring to the diagram. So, yung titignan natin is yung direction ng load. So, downward means negative. So, dalawa lang yan, alin lang sa dalawang yan. No? Either pag ganun yung drawing natin or pag ganun. Okay, for the curve. Again, first degree curve to. So, second degree curve yung ating magiging graph sa baba. Okay? So, alin ba dito sa dalawa? So, kung mapapansin nyo, di ba, from 0 to 360 means you are increasing in magnitude. But, negatively. So, increasing negatively, ano yun? Ito yun, di ba? So, increasing negatively. Okay, so pag ano yan. Hindi nagtugma na. Yun, ang pangit. Hirap na. Ang hirap i-going. Okay, okay na yan, no? Disregard may drawing yun kung hindi naka-scale. But, sundan na lang yung magnitude. Hindi pa rin naging sapat. Sige nga. Okay. Ang hirap. Sige, okay na yan. No? So, this will be first degree. So, obviously, this will be a second degree curve or a parabolic curve. Okay, so, i-shade lang natin para na-emphasize yung boundary ng area. Okay, now, ito yung area na ating i-reference, no? For drawing our moment diagram. Okay, so with that, okay, lagyan natin ng label. Now, this is area 1, area 2, and then, yun na. Now, so how can we compute for area 1 and area number 2? Okay, so we need the distances. No? Kasi meron tayo ditong discontinuity or meron tayong segment. Okay, so ano ba yung value ng x na to? Of course, kung nakabit mo yung value ng x, that yung kabilang side that will be 12 minus x, right? So, how can we resolve this one? Diba? Pag second degree, we have a parabolic curve. No? A parabola is a second degree curve. No? And with that, we can apply what we call the square property. Of parabola. Okay, anong formula ng parabola? Diba x squared is equal to 4ay. Okay? Pagka naman yung axis ay nasa kabilang side, no? Y squared is equal to 4ay. Diba? Ano meron tayong parabola dito? Ito yung half portion ng parabola and supposedly kapag binuo mo yan, yung other half is nasa kabilang side. So we have here the apex or yung a point wherein mag-occur yung inflation tuloy. Mag-occur yung point of inflection nung naghalo ng engineering economy tsaka itong mechanics na point of inflection wherein may zero slope, we have zero magnitude for our loading. No? So, yan yung magiging parabolic curve natin and this is our axis of symmetry. So, that is why yung ating equation na naka-square yung x. No? But obviously, applying the square property of parabola. No? Okay, how do we apply this one in order to solve for x? Diba? Parang ano lang din yan, ratio and proportion sa triangle. Using similar triangle. But this time around, we are to consider itong whole parabola. No? So when we are to consider the whole parabola, ito yung mangyayari class. No? So, that will be what? Paano siya class? Isunod. Okay? Ganito, no? We have a magnitude here of 1,000 at the peak, at the summit. So 1,000 all over x, okay, is equal to, ito class, no? Do we write this one as 1160? No, kasi we are to consider the whole parabolic or parabola, no? So ang reference natin dito ay kumbaga, we are to consider the whole parabola. So the magnitude here to be indicated is 1,000 plus 1,160, that is 2,160. Okay, so divided by, of course, 12 minus x. But take note, class, square bracket of parabola, it should be squared both values ng ating x distances. No? So can you complete for the magnitude of x? Ilan yan? Again, yung 2,160 galing yun dito ng 1,000 and 1,162. So considering the whole parabola, no, that is 1,000 value and 2,160. Okay? So ilan to, class?
7.876, sir.
Ilan?
7.876.
7.876. Okay, so sige, tingnan natin.
Mali
X
pala,
is,
sir, mali pala.
sige. Para mabilis kasi solve ng calculator niyo, no? Mag-indicate, mag-input kayo, pag nag-shift solve kayo, no? Diba hihingi ng value ng x yan? Okay?
4.858 po ba, sir?
Okay, so tingnan natin. 4 point, ayan, 85, 85,
859 pala, sir.
859. Okay, so sige, let me double check. Agad, di ba, let's say, tinake nyo sa calculator nito, then you press shift, solve. Shift, then hihingi sa calculator nyo, solve for x. Para mabilis mag-solve yung calculator nyo, magiging kayo ng value na malapit sa assume value ng x. Diba 12 naman yan? So, approximately, magbigay kayo initially ng value ng 5. Okay? Para mabilis mag-solve yung calculator ng value ng x. Okay? So, ang solve ko nga rin is 4.859. Kasi kung hindi kayo magbibigay ng value ng x, no, yung calculator mag-solve yun, tuloy-tuloy. Okay? So, bibilis yung computation na may karoon kayo na initial input sa value ng x. Okay, so 4.859. Okay, so meaning itong x value is 4.859 and ilan to? Kabilang side. So minus alpha x, diba? That is 7.141. Okay, so can we check? No? Para tayo ay tuloy-tuloy with this one. Do we have a same? Okay, that's the problem. Okay, 8.165. Okay, we have an error here. No, wait, let me debug. 160, 1,000, log x squared. 1,000 plus 160 is 260. Tama na. Then 4 minus x squared. Then hold for a moment. I'm double checking my input. Okay. Ito yung naging mali ko pala, class, no? Kindly, okay, ito siya, no? Inassume ko siyang triangle. My bad. Okay, class, ito siya. No, tapos sa triangle dito. Okay, ito siya. No, this should be 12. Okay. Kasi we are referencing at this point, no, as the origin. So, yung ating distance from this axis of symmetry is, of course, x for this one, no? Then 1,000 yung ating um, magnitude, then 160 for the total. Then yung x distance is, this should be 12, no? Then, of course, we square this one. Can you give me the value of x nga? Napasarap sa triangle. Ilan na yung value ng x here? X. Yan. Okay, can you give me the value of x here? Kapag ito na equation, 1,000 squared. 1,000 all over x squared. Is equal to 2,160 all over 12 squared. Kailan na ito, class? Can you compute? This should be around 8 point something.
8.165.
Okay, so tama na to this time around. Napasarap sa triangle na. Okay, for the parabola na we have to consider the whole curvature na on our equation. Okay, so 8.165. Okay, so kaya pala hindi siya nakaano sa ating ang tawag dito, hindi siya proportional. Okay, so 8.165. Okay, x is equal to, wala. So 8.165. Now, of course, 12 minus x, that will be 3.835. No? So this will be 3.835 for the distance. Now, we are ready to solve the areas. No? For the areas, how can we do it? No? Ano yung formula ng spandrel? That's 1 all over n plus 1. Okay? Where n is the degree, no, then base times height. Okay, so what do we have here? No? Areas. Okay, for area number 1, okay, di ba we all know that this portion ng area, no? Okay, lagyan ko lang ng almost hidden line. So, di ba with this one, ito yung area ng um, rectangle, no? Ng kabuuan. So, that area minus this area ng unshaded region is equal to this area 1. Okay, so with that, can I write this one sa officialist equation? That will be what? Area ng rectangle ng kabuuan, that will be base 8.165 multiplied by the magnitude nito, which is 1,000. Of course, minus itong area ng unshaded region. Whereas ang ating unshaded region is spandrel, no? Second degree spandrel. And with that, itong second degree yan, so ang ating factor is of course 1 all over n plus 1. So add lang tayo na isa, 1/3, no? So 1/3 base, ano yung base natin? Yun pa rin naman, no? Yung 8.165 times height na 1,000. Okay? For the other way around is that, syempre kung alam niyo 1/3 tong portion na to, edi itong kabilang side is 2/3. So the area 1 is 2/3 base times height lang. So that's the other way around. Okay? Pero, then just to emphasize our solution, ginawa ko na ganito. Okay, so, ilan yung class? 8.165 times 1,000 minus 1/3 ng 8.165 times 1,000. Ilan to, class? 5,000? Parehas lang ba? 5,443.33. Same lang? Anyone? Same lang ba? Yung na-complete na. Same? Can you confirm? Before I proceed. Guys, can you confirm? Same?
Yes po, same lang po.
Okay, so now this is for area 1. Then how do we solve area number 2 naman? Okay, for area number 2 class, we cannot apply, di ba, if you are thinking na parang, di ba, this is a spandrel naman, no? Okay, then we can just simply apply um, yung formula na 1/3 na base times height. But in this case, hindi siya applicable. Since this is not the apex of our parabola, no? Or our curve. No? So we cannot apply that equation in particular. Okay? With this one, hindi rin yun yung magiging apex on our um, parabola. No? Okay? So, hindi natin siya ma-apply yung area na yon. Ang kailangan natin gawin is that we consider this whole, no, parabolic segment, okay, in order to compute for area number 2. Okay? So, how do we do that? No, syempre, i-isolate natin itong buong parabola. No? So, i-isolate ko muna yan. Okay? So, yeah. Okay, so this is 1,000. This is 1,160. Okay, and then, ito siya class, no? If we consider the whole parabola, then we can consider a full rectangle, no? Isang malaking rectangle. Okay, anong dimension ng malaking rectangle? Of course, that will be, ito ay 12, tama. No? And then, itong kabuuan na to is in total, that is 2,160. Okay? Now, again, this is area 1, no? Computed kanina, no? Meron naman tayong value na. Then area 2 is unknown. In order for us to compute for area 2, ang pwede natin gawing consideration dito is that, okay, itong area ng kabuuan ng rectangle, no? Itong kabuuan, minus itong area na to. Okay? Lagyan na lang natin na number third area. Okay? Minus, of course, this region, no? Ito naman. Na, ano natin, area number 4. Okay? Fourth area. Okay? So, then, ano makikita nyo matitira? Ito na lang, area 2, di ba? So, that will be on our equation. Area 2 is equal to area ng rectangle as a whole. Okay? Minus area number 3. Okay, ito yan. Itong portion na to. Minus area 4. Then, ito yung matitira. So, area 4. Now, isolve muna natin, no, isa-isa. Area ng rectangle is equal to, yung kabuuan is simply 12 multiplied by 2,160. Right? So, ilan to class? Can you give me muna? Yan, before we proceed. Anyone?
25,920.
25,920.
920.
Okay, so correct. Now, for area sub 3, di ba? This is the parabola, no? Parabolic segment. 2/3 base times height. Kung sa spandrel, di ba, 1/3 yan, yung kabilang side. So, pwede rin na itong buo minus 1/3 base times height. Di ba? But in this case, kung alam natin na 1/3 yan, since second degree yan, then itong portion na to is 2/3. Right? So, area sub 3 is 2/3 base 12 times height of 2,160. Ilan to class?
17 to 80.
17 to 80. Okay. Parehas, no? Parehas lang. So, nung na-compute ko din. So, area 3, anong ulang na lang? Area 4 na lang. So, area 4 will be, paano ito makukuha class? Diba? We all know that area 1 kanina, computed naman natin kanina, di ba? Area 1 is 5443.33. So, kailangan lang natin i-minus ng area 1 sa kabuuan nitong upper rectangle. Within yung upper rectangle, di ba? Ang dimension is 1,012. No? So, that will be area 4 is 1,000 times 12 minus area 1. Ano yung area 1? 5443.333. Ilan to class? For area sub 4. 1,000 times 12 minus 5443.333.
6556.667.
6556. Yes, para saan? 667. Now, we are ready to substitute the values, di ba? So, area ng malaking rectangle is 25,920 minus 17,280, right? For area sub 3 minus 6556.667. So, ilan to? 2,520. Go ahead if you have the answer.
Two thousand 2,083.33.
2,083.33. Okay, so ito yung area number 3. Area number 2 pala, no? Which is yung kailangan natin. No? So, yun na naman kailangan natin area, no? Area 1 and area 2. Kaya din lang tayo nagtagal sa area 2 competition, no? Pero mukhang matagal lang yun. At nagdi-discuss ako. No? So, area 2. Now we are ready to completely draw the moment diagram. Okay, so for the moment diagram, may areas naman na tayo ng bawat figure, right? So, good to go na. No? So, with that moment diagram, sounds fit yung unit natin, and then zero value for our reference dito. So, for area 1, anong meron tayo? Ano yung magnitude? It is what? 5,443.33. So, the moment at this point is 5,443.333. Okay? Now, ano yung ating graph? Diba? Pag ganun ba yan or pag ganun? No? So, again, wala naman tayong moment loading sa taas, diba? So, zero lang yan dito. Okay, paano drawing yan? Pag ganun ba yan or pag ganun? Okay, so, refer tayo dito sa DT. No? So, again, this is positive for the graph, no? Nasa taas ng horizontal line. So, positive, this is decreasing na. So, decreasing positively, decreasing positively. Okay, ito yan. So, yan. And then, of course, 5,443.333. So, yung area sub 2, okay, this is negative, no? So, we need to subtract this magnitude, no? Or if you want to, no? Ang gawin nyo is that under solution, lagyan nyo ng parenthesis to then to indicate negative value for the area. So, negative pa rin to. So, 5,443.333 minus, no? Ilan? 2,083.33. Ilan yung class? 5,443.333 minus 2,083.33. Ilan yung class? Anyone?
3,360.
Okay. Correct now. 3,360. So again, how do we draw? Diba? This is negatively increasing na. So increasing from this segment now. Again, from 0 to here, diba? This is increasing in magnitude. But negatively since nasa baba yung ating graph. So increasing negatively. So ito yung ating graph. Okay. So, yan. Now, meron tayong 3,360 dito na moment. But take note guys, meron tayong reaction moment here which is counterclockwise. Meaning on our equilibrium equation, di ba, that the assumption is this is one is negative, di ba? So 3 to 60 minus counterclockwise moment na 3 to 60 negative. So of course, babalik yan sa zero. Okay, so this will be our moment diagram. Now, therefore, maximum moment is 5443.333 pounds feet per hour units. And maximum shear is, ano meron dito? Negative 1160 pounds yung maximum. Okay, so can we check this one on the result sa equation method on the module, di ba? I think this is same lang naman na. Okay, yesterday na yan, 5443. Okay, same lang. Right, so then the maximum share is negative 1160. Okay, same lang with the result. Using equation method, also ang tawag dito, area method. Okay, so let's save this one. Okay, supposedly class, meron pa akong i-discuss na isa pang tawag dito. Example, prior we proceed to the moving load. No? But I think we need to go to moving loads already. What I will be doing is just, I'll send you the solution for this one. Both equation and area method. Okay, para meron yung additional set of example. But basically, you have your module, no? Ang dami dong solve problem. No? If you want to check, meron yung mga solve problem. Okay, sa inyong module, you just need to take time to review. Okay, but of course, it's just not review. No, I encourage you to solve it on your own and then verify the result here. Okay, and again, on your module, the difference might be yung assumption natin ng positive and negative direction for the equilibrium equation ng summation of moment. Yun lang yung difference, no? But the rest are all similar, di ba? Nakita nyo yung cutting plane, ang assumption dun is similar lang sa ating positive direction. Okay? Positive yung moment pag ngiti yung beam. Positive siya pag iikot yung clockwise. Okay? Kindly check all those example, no? Okay, other than this example that I will be sending to you. So we can proceed with the moving load topic already. Okay? So, now, as long as you know the concept naman, hindi kayo maliligaw with our with the procedure. Okay? Now, class, before we proceed to the moving load topic, okay, let me show you some example here. Wherein, okay, class, are you with me with this problem number 2 on your screen?
Yes po.
Okay. So, this is actually a solved problem using area method. No? So again, you have to solve the equation, the reaction, then you can draw the diagram. Okay? So, for the shear here, kung mapapansin nyo, di ba? Do we have a force here at this end segment? Okay? Wala naman, di ba? So, flat pa yan until this point B. Ngayon, bigla nagkaroon loading na 20. So, bumaba ng negative 20. Then, until prior point C, di ba? Negative 20 pa rin yan. But, pagdating ng point C, meron tayong support reaction na 20. So, balik sa 0. Okay, so negative 20. Now, for the moment diagram, kung mapapansin nyo class, okay, if there is no loading na moment, no, on our beam, then di ba lagi nagsisimula naman sa 0. But in this case, if there a certain value ng moment, no, kahit pa yung sa segment B or C or at A, what we are doing is just para lang din siyang unit load, no? Taas baba lang yan on our diagram. So in this case, di ba, this is positive 40 kilonewton on our assumption sa equilibrium equation, di ba? Positive means, clockwise means positive. That is why ito ay positive on our graph. So tumaas siya ng 40 in magnitude. Now, do you see any loading? No? Or rather, we are, after nyo mag-graph to no, for the 40 kilonewton meter, refer to the shear diagram. Okay? Do you see any areas here that will change the magnitude of 40? Wala naman, di ba? So, continuous yan until at this point. Now, at this point, no, at point B, 40 kilonewton meter per yan, no? But of course, meron tayong 20 kilonewton to change and this loading to change the moment diagram. So from 40, again, and take the area, no, itong ating shear. So 40 minus 40, it will bring back the value to 0. Okay, so 0 na yan, then are you seeing other areas here after this point? No, hindi pa nga ito pantay, dapat pantay to here. Okay, so 0 yan, then until this one, 0 yan. So we don't have any area under this particular shear diagram. So what I'm trying to emphasize is that pag nakita kayo ng moment loading, okay, ano nangyayari? Kuha pa tayo ng example dito. Here with this one, may moment loading here, no? Or there's a couple of loading, no? Anong nangyayari dito? Okay, we have a 25 kilonewton meter. Now for the moment diagram, di ba? The area of this one, class, are you with me muna for problem 8? Sige nga. For problem 8. Are you with me with
Yes
problem
po.
8? Okay, so for problem number 8, okay, upon solving the support reaction, di ba, mag-drawing nyo naman yung shear diagram. Then for the moment diagram, okay, siyempre, you check the loading, di ba, wala naman tayong moment here. So we just simply refer to the area ng shear. So the area ng shear is, of course, that will be what? 10 yung magnitude, and then yung distance is 1. So 10 times 1 is 10. So that is why 10 yan. And then first degree, so 0 degree pala, then first degree to. So 10. Ngayon, we have a moment loading, no? Na 25 kilonewton meter counterclockwise. Counter means negative. So that will be what? 10, mababawasan siya ng 25. So 10 minus 25 counterclockwise, negative 15. That is why nagkaroon ng drop down here. So kung clockwise positive, ano mangyari sa ating moment diagram? Pataas naman yun doon. Then bago nyo consider itong sunod na mga areas here. Okay, so class, this is it for your practice. No? I-check nyo yung mga sample problem here. No? Then apply our core concept. No? Ang importante lang naman din. Alam niyo yung core concept din. Complete for the reaction, kung equation method yan. Take the segment. Complete for the draw the free body diagram. Take the moment and shear equation. Then plot the diagram. Okay, wag lang kayo malito doon sa, di ba, how to draw, di ba, using yung ating guide na DIDI, no? For positive and negative positive values, no? How can we connect the datas, no, on our graph? Okay, so now we are up to the last topic, okay, for the day. So okay, for the last topic, class, this is all about moving loads. Pero we discuss this one very briefly lang, no? Kasi ito yung madaling topic lang naman. I would say, kung masusundan ninyo yung flow ng discussion, no? But of course, kindly listen attentively. So, class, for our, as you can see now with our unit load, okay, nag-occur yung mga maximum moment under such loading, di ba? Let's say for 6,000 pounds, 4,000 pounds, 2,000 pounds, di ba? The moment occurs right away just below the unit load. Okay, nakikita niyo yung mga moment values na yan. And as you can see, class, if you will be comparing the result, no, saan nag-occur yung maximum moment? It occurs wherein yung ating shear ay nag-zero. No? So, from our shear diagram, di ba, nag-zero yan at this point. So, you're expecting that the maximum moment will occur at this particular point. No? At point C under the 4,000 pounds loading. Okay, mag-observe pa tayo dito. No? So, ano pa yung may mga loading lang ng mga unit load. Okay, so meron pa ba dito? Okay, how about sa kabila? No? Just to give you some observation lang. Meron pa ba? Okay, ito na lang. No? So, for this P value, as you can see on the moment diagram, no? Just under the load, dito nag-occur yung mga maximum moment, and of course, the maximum value will occur at a point wherein nag-occur yung zero shear. No? So, doon ako yung maximum moment. At ko ba ini-emphasize to class? Kasi for the moving load topic, we only have concentrated load or unit load. Okay? So, nasa na yung ating presentation here? Wala. Okay, let me open muna my presentation for the moving load. Okay, so wait for a while. I think we can finish just before 11:30. No, sige. Then we are dismissed already. No, after that. Okay, so nasa na yan? Mech 511. Wait for a while, guys. Okay, class, are you connected? Can you still hear me clearly right now? Can I confirm? Can you confirm you are hearing me clearly right now?
Yes po.
Okay, so now for the topic of moving load class, now I will not open yung presentation natin sa module, but I will just be discussing the core concept here. No? So when you say moving load, di ba, ano yung naiisip niyo? Okay, it could be a car, no? Trucks, no? Wherein, di ba, yung loading ng mga kotse, ng ang tawag dito, ng trucks are transferred, no? Let's say you have here a car, no? Then of course, meron yung weight, no? Kung passenger or no cargo niyan, then it is transferred on the wheels, no? Or on the axle. And then it is represented by a um, concentrated load, wherein we simply call this one as a moving load. Kasi di ba, let's say that car is to pass as a bridge, no? For example, di ba? Let's say the bridge is a 20-meter span bridge, no? This is the beam of your bridge. Then, di ba? Pag dumaan yung kotse na, let's say this is 10 kilonewton, then 20 kilonewton yung harapan. Okay, let's say galing from left to right. Okay? Um, we don't know, no? Okay, kung saan yung positioning ng moving load, wherein it will produce the maximum and the maximum, no, shear and the maximum moment. Kasi di ba, we are taking into consideration, no, kung alin ba sa position ng moving load, no, on our beam, yung magpo-produce ng maximum shear and moment. Kasi yun naman yung kailangan natin, di ba? In order to design our structure, itong beam, di ba? Upon knowing that, no, kung ano yung position na yun, then we can already compute for the maximum shear and moment. Okay? So, ano pa yung mga example nun? Di ba? Pwede rin yung crane. Di ba? Kung mapapansin niyo yung crane. By the way, class, you can observe sometimes, no? Or dapat lagi, no? Pag, di ba, bago pumasok ng tulay, nakalagay doon kung ilan yung maximum load, no? Na pwede pumasok sa tulay na yun. Let's say 10 tons, no? That simply means, sinasabi doon na ano yung maximum vehicle na pwede lang lumisot doon kasi doon nakadesign yung ating tulay, yung ating bridges. For example, yung beam, yung bridge. Diba? Nakikita niyo ba yun? Sino nakakita ng class sa bago mag-enter ng tulay? Nakalagay 10T, minsan bilog lang. So that's an advisory sign na 10 tons lang yung maximum na pwedeng dumaan dun sa tulay. May nakakita na ba sa inyo nun? Anyone? Anyone, do you see that sometimes on the road?
Yes po.
Diba? So, yun yung ibig sabihin nun. No? Okay, kasi di ba, a car or a truck is a moving road in that case. So, ina-advise to, no? Yun yung maximum lang na kayo dumaan. And also, di ba, meron tayong tinatawag na, let's say sa crane, di ba, yung crane is, of course, di ba, anong nangyayari sa crane, di ba, nag-move yung ano yan, yung tension wire here, carrying the load, di ba, umaabante yan or umaatras. Okay? So, gumagalaw yung ating unit load here in that case. Let's say horizontal yung ating truss, yung ating crane, di ba? Let's say this is the crane, no, coming from this operator. Di ba, anong ginagawa ng operator? Di ba, pag transport niyan, iikot lang naman or pwedeng yung mga load is gumagalaw. Okay, so with that, yung crane, meron yung capacity wherein naka-design din mismo itong beam ng crane. Okay, so kung ano man yung design na yung designer dito, then dapat masunod yun kasi kapag sumobra yun sa loading, no? So without considering that is a moving load, then the tendency is that magkakaroon ng failure sa ating beam. And then din natin yung dinesign. Okay, so um, ano pa yung mga kaya pa example ng moving load? Yun lang naman, no? So, in order to analyze moving loads, yun yan, kailangan natin malaman kung saan ba natin ilalagay itong mga moving loads sa ating beam in order to produce the maximum values for shear and moment. And that's it. No? Kasi pag nakuha natin yung shear and moment maximum, then pwede natin ma-design yung ating beam. Diba? So with that introduction, let's have our computation here to formally illustrate the method being used when we are to analyze moving load. Okay? So, ano yung example dito? Okay, problem 453. Okay, a truck with axle load of 40 kilonewton. Plus, can I check, are you with me with this problem for 53? 453? Ito na yung last problem natin for this meeting. Kasi yung isa ay illustrative lang. Ituturo ko lang sa inyo na mabilis. Are you with me with this last problem to solve?
Yes po.
Okay, so a truck with axle load of 40 kilonewton and 60 kilonewton on a wheelbase of 5 meter rolls across a 10-meter span. Bitten, no? But I guess this is a bridge, okay, or a certain structure like that. No? Then compute the maximum bending moment and the maximum shear force. Now, with this one, no, um, let's represent the axle load. No? This is the moving load or yung load transferred sa gulong ng mga sasakyan. So, for the truck, 40 kilonewton yan and a 60 kilonewton axle load. Now, ano yung wheelbase? That is the distance between the wheel. No? So, this is 5 meters. Okay? Plus, the first step in analyzing moving load is that um, we need to what? We need to locate the resultant of this moving load. No? So that yun yung magiging reference natin on our positioning later sa ating beam, which is 10 meter. So, isa-isahin na natin yung procedure. No? Now, diba ang resultant dito? Okay, using Barignan theorem on your P6, diba? We can just simply compute for the resultant of these two forces. Then we can locate that at the center of what? Center of gravity of these forces. No? Kung saan siya mag-act. Okay, paano ba yung kinocompute? Just like a moment equation, ganun lang din naman yun. No? The resultant is equal to the summation ng component ng mga forces. Okay, so this is R, then we have to compute this x distance from a certain reference point. So we take the reference as the location ng 40 kilonewton load. Okay, so this is the zero point reference here ng x. Now, how can we compute for R? Di ba? R is simply summation ng mga forces, which is 60 plus 40. So, R is simply 60 kilonewton. Okay? Now, to take the location ng ating resultant, that is what? Taking a moment, about 40 kilonewton will lead to what? Ilan yan, class? Okay? the resultant is equals to the summation ng component moment ng bawat forces. Okay, so resultant is equal to summation ng moment ng bawat component. But in this case, I take this point as the reference point. So Rx is equals to 60 times 5. Okay, so R is what? 60 kilonewton. Mali pala ito. This is 100 kilonewton. Okay, why did that you correct this one? 60 plus 40 is 100 na. 100 kilonewton. So 60 times 5. So that will be 100 times x is equal to 60 times 5. Ilan to class? 300 divided by 100. No, 60 times 5 is 300. Divided by 100. So x is equal to 3 meters. Now, upon determining the location ng resultant, then we are ready to proceed with step number 2. No? So, for step number 2, what we will be doing is that we will position yung moving loads such that yung center line ng ating beam will divide this location ng resultant and the maximum unit load. No? So, yun yung ating method here. No? Okay, let's draw. Okay, ilawin natin yung beam. Okay, the beam is what? On the given. That is 10 meters, right? So, 10 meters. Yan, 10 meters. Now, of course, this is the center line of the beam. Diba? 5 meters both ways. So, 5 meters. Or rather, center line na lang. Okay. In order to compute, this is for the maximum moment, Mmax. Okay. For the maximum moment, we need to locate the moving load such that, okay, are you with me nga? Can I have confirmation? Mamaya disconnected na kayo or what? Okay. Are you with me with this one? Okay, still okay. We need to, to compute for the maximum moment, we need to locate these moving loads on our beam such that, okay, itong resultant and the maximum unit load. Ano ba yung maximum unit load? Diba itong 60? Hindi naman itong 40. No? So, we need to locate this R and 60 kilonewton such that hahatiin niya ng center line ng beam. With that, yung position na yan ng moving load, yan yung magbibigay sa atin ng maximum moment. Okay, so paano yan ilo-locate, di ba? So, this is the 60 kilonewton load. Of course, natin yan, di ba? Itong gitna nito. So, kung yung gitna niyan, that will be 1 meter both ways, di ba? So, 1 meter. Lagay ko na lang na 1 mga dito, no? Then, of course, ano sunod? Okay, kung 1 yan, then the other side 1 then for the location ng resultant. Okay, so kung 1 yan, then, of course, ito ay 3 meters going to 40 kilonewton. So, 3 meters. So, 3 meters, 1 meter, 1 meter, still 5 na. In total distance ng 40 and 60 kilonewton. Okay, let me zoom this in. Now, with that, this is already the location, no? Ng moving load na magbibigay ng maximum moment. Okay? So, kung 3 meters to, 1 meters to, ilan to class dito? Okay? 3 to 1, so 5, 4, then 5 yung ating center line, di ba? So, 1 to 1 meter, and then, of course, we know the distance from 40 to 60, the wheelbase is 5 meters. And then, this one, itong distance is, of course, ilan to? 4 meters na lang. Okay? Now, maglagay tayo ng letters na. Point A. Then, let's say this is point B. Okay, so ano gagawin natin? Siyempre, to compute for the maximum moment, we solve first for the support reaction. Okay, so this is AY Then this is of course By for the reaction. Simply supported lang naman yung class na. So, summation ng force vertical is equal to 0. So, for reaction. Summation of force vertical equals 0, positive going upward. We can note that to solve an unknown with summation of force vertical. So, summation ng moment tayo. Okay, summation ng moment about point A is equal to 0, positive clockwise. So, that is, of course, By na negative times moment arm of 10 meters span. Okay, plus 40 times 1 plus 60 times 6. No? Okay, is equal to 0. Now class, itong resultant na to, hindi natin siya nilalagay kasi we're just simply using that um, resultant location just to order for us to locate the moving loads such that it will give the maximum value ng moment. Okay, so on our equation, hindi yan mag-reflect. So, ilan to class for By? Anyone? If you have the answer, you can already say the answer. Go ahead. By is what? Anyone? By is B sub Y, rather.
40, sir.
40, correct? So, 40 kilonewton. Then, kung 40 kilonewton yan, diba, summation force vertical, okay? 100 naman to, then 40 to. So, obviously, this will be 60 kilonewton. Okay, hindi ko na isa summation force vertical, but that's too obvious. Na. So, kung 60 kilonewton yan, okay, to get the maximum moment, okay, you can just simply cut na yung beam under the 60 kilonewton load since we are expecting na ito yung magbibigay ng maximum moment. Diba? But this time around, since alam naman natin yung area method, huwag natin gawin yun. Mag-alam na lang tayo dito. Okay, mag-area method na lang tayo. Okay, so ganoon din naman yung result na. Same answer. So with that one, that is 60, right? From 0, this is shear. 0 to 60, right? Going upward for the reaction. 60, and then wala naman tayong loading at this point. So 60, then we have a 40 load. 60 minus 40, that is 20, of course. Then continuous na yan until prior this point wherein meron tayong 60 kilonewton loading downward. So 20 minus 60, that's negative 40. Okay? And then going here, meron tayong load upward na reaction 40 kilonewton. So babalik sa 0. So ito yung ating shear diagram. And kung mapapansin nyo class, we have here a point wherein nagkaroon ng zero shear. So we're expecting at this point na yun yung maximum moment. And obviously that is under the 60 kilonewton load. No, that's what I mentioned kanina, no? On our investigation, di ba, sa mga example problem. Okay, so with that, okay, applying area method pa rin, no? So, okay, so lagyan natin ng 1, 2, and 3. No? So, area 1 is base times height, which is 1 times 60, that is 60. Of course, area 2, base times height, that is 5. 5 times 20. Okay, positive pa rin. No? That is 100. And area sub 3 is base of 4 meters times negative 40. Okay, so negative 160. Okay, so first degree lang yung ating graph na. We don't have the moment at the subpart. Okay, so that is 60. So from 0 to 60. Then, of course, 60 plus 100 plus the area here. That is 160. Okay, straight lang ulit. And then, 160 minus, of course, area 3 that really bring back this magnitude ng value to 0. So this is the moment diagram. Okay, and then, yan, meron tayong, alam na natin yung maximum moment. No? So meaning yung load na yan, itong moving load na 40 kilonewton will give maximum of 100 kilonewton meter. But take note, at this particular at this particular position, no, we're in, paano natin nakuha yan, di ba? We use this method, no? I-locate natin yung moving load in this way, no? Na nahati na center line yung location resultant and the maximum unit load. Now, for the maximum shear, ito yung pinakamadali kaya pinanghuli ko, no? Lagay ko na lang dito sa side. For maximum shear Vmax. In order to complete that, ang ginagawa natin is that nilolocate natin yung locate the maximum unit load ng moving load at the support. Okay? So, with that, no, tandaan nyo lang, ganun lang yan. No? So, 60 kilonewton, no? So, ang gagawin natin, di ba? If we locate this one ng 40, hindi na magbibigay ng maximum shear. Yung maximum shear will occur kapag yung maximum unit load ng moving load is at the support. So, in this example, ito yan, no? 40 kilonewton and 60 kilonewton at the support. Okay, so of course 5 meter naman yan. Then we have a 10 meter span, so 5 meter itong half. Okay, so now we are ready to complete for the reaction. Okay, so this is AY and this is BY. So summation ng moment about 0.8 is equal to 0, positive clockwise. So that will be, of course, negative BY times 10 plus 40 times 5 plus 60 times 10 is equal to 0. Can you give me BY here? Or reaction at B, vertical, ilan to? Anyone, ilan to? This is the last, kasi maximum shear in moment lang naman kinukuha natin. Ilan to, class? Anyone?
80.
Yes, correct na. BY is 80 kilonewton. Okay, now class, ito, laging ganito, no? The reaction here at the support ko rin doon nakalocate yung maximum unit load ng moving load. This is already it equates to Vmax. No? So, let's verify this case, no? But of course, just for the purpose ng computation ng kabuuan, summation of course vertical equals 0, positive upward, AY will be of course 100 minus 80, diba? 100 minus 80, so that will be 20 kilonewton. Okay, so BY is 80 kilonewton and AY is 20 kilonewton. Okay, if we draw the shear diagram using area method, okay, anong mangyayari dito? Diba? Aangat ko ng 20, right? So, then 20 minus 40, that is negative 20. And then negative 20. Going here will be what? Of course, negative 20, then we have a 60 loading downward, so negative 60. Negative 20 minus 60, that is negative 80. And of course, may positivity tayo to return this value. Okay, so our maximum shear here is 80 kilonewton. No, Vmax is okay. How can we determine yung ating sign ng maximum shear, di ba? By the means of the shear diagram. Okay, so itong kanina na nilagay ko is of course that's only for the magnitude. Okay, but I just verify my case here na ang maximum shear will occur no, under the maximum unit load ng moving load if it is located at the support. No? So Bmax is negative 80 kilonewton. Okay, now we are done with my last example to compute, but I have to show you this illustration. No? Nasaan na yan? Moving loads. Okay, same lang naman yung procedure if let's say tatlo na yung gulong. No? Okay, kanina dalawa lang, no? Or tatlo, kahit kaya na yung apat or lima. Okay, let me just show you here. No? May solution naman to. I'll be compiling this one. No? Don't worry. Okay, so na yun. Dito. Okay, yung tatlo yung loading. Ayan, this one. Class, are you with me with this last problem just to illustrate lang? 4, 5, 6. Can I confirm? Before we proceed. So we can dismiss already. Anyone? Can you confirm this problem 4, 5, 6?
Yes po.
Okay, so ito siya class, no? What do we have here? We have 3 axle load, no? 3 wheel loads na roll at a unit across a 44 feet span. Okay, this is the span ng bridge or ng beam, no? So, pag walang sinabi, it is always simply supported. No? Typical bridges naman is simply supported yung ating support condition. Now, we have 3 loads here, 4,000, 8,000, and 6,000. Naka-indicate naman yung distances in between. No? So, 9 feet and 18 feet. Now, these are the loading. No? 4,000 pounds or 4 kips, 8,000 pounds, 8 kips, and 6 kips. Then again, the method ganun pa rin. You need to locate the resultant R. Okay? So, upon locating the resultant R, okay? R is still summation lang ng forces, diba? Then, locate the resultant R. Take the moment center for your moment arm, moment computation. Okay? Itong typically laging sa left naman. So, to compute for distance x. It's up to you kung kaliwa or kanan, pero typically kaliwa naman. Then upon solving the resultant and also the location ng resultant, okay, yun naman importante dito yung location ng resultant kasi we neglect the magnitude of R after we located the moving load such that it will give the maximum value ng moment. Okay? So, with this one, anong na-complete na value ng x 13 feet? No? So, kung 13 yan, no, yung kabilang side, this is 27 minus 13, so 14 to. No? Tama? So 27 minus 13 is 14. Okay? So ang gagawin niya is that you need to locate itong moving loads na to, itong tatlo, such that it will produce the maximum moment. Wherein, di ba, ang gagawin natin is that yung center line, hahatiin yan yung resultant and yung maximum loading sa moving load. Ano ba yung maximum dito? Di ba itong 8 kips, hindi naman yung 6. Diba? So 8. So ilalocate natin itong R and 8 kips wherein mahati yan by the center line. Ito class example sa module, ang ginawa ay chinek na lahat. No? Yung una is that itong pinalocate nito no, sa unang computation, yung center line, hinati itong resultant and P1 or kips. No? Ito yung magnitude ng moment. Okay? Yung second is that ito na no, yung ating method wherein hati ng center line ng beam yung resultant and the maximum loading na 8 kips. So, in this one, ito yung value ng magnitude ng moment, 127. Okay, compared to 98, di ba? Mas malaki ito. Then, we can verify the case lastly with this one. No? Ang ginawa is that ito namang 6 kips loading and the resultant yung sinubdivide no? In terms of location, the center line ng beam. And the computed magnitude is 92,000. No? Still, mas larger itong maximum moment computed kapag ang positioning is such that ito yung resultant and ito yung maximum unit load ng moving load, no, at the center line. So, ito class, I'm good with this solution no, kung ito lang yung ginawa ninyo kahit di na itong the other solution. Kasi understandable naman no, na on our method na the maximum moment will occur with this location na, di ba, pinati ng center line as per position itong resultant and the maximum unit load ng 8 kips. Okay, so that will do. Okay, and then the maximum shear, ang gagawin nyo lang is that, syempre, no, ang maximum natin na load is 8 kips, di ba? So kung ilalagay mo yung 8 kips sa support, malalaglag yung 6 kips, di ba? So you need to locate na yung loading is nasa support. No? So yung 4 kips yung nasa sa support and mas malapit itong 8 kips sa support. Kasi yung isang scenario is that pwede na ang ilagay mo sa support itong 6 kips. No? But this time around, mas malayo kasi sa support yung 8 kips, yung mas heavier load. So mas magiging malaking reaction at the support. No? Kapag itong 4 kips yung nasa support. No? 9 feet lang yung distance yan, di ba? So obviously mas mabigat yung bubuhat na support dito. Compared na ang position is that nandito sa kabila yan. No? Itong 6 kips naman yung nasa support R2. Okay, and then again, the reaction is the maximum shear already. No? Okay? So yun lang yan. No? Do you have a question for moving load topic? Class, before we dismiss? Clarification? Do you have any clarification with moving load topic? Any question? But is that from module 1? What are you trying to say? Any question ba? Go ahead.